Now, you might be thinking, do the particles in matter remain stationary or do they move? To answer this, think about what happens when you put an unlit incense stick in a corner of your room. Can you smell it from some distance away? How close do you have to go near it so as to get its smell? Now light the incense stick. Can you smell it from some distance away? If yes, how? Some particles from the incense mix with the air and take space between the air particles and reach your nose. For the next experiment, we would need 2 glasses of water, some honey and ink. So again we have 2 glasses of water here. I'll add ink or food coloring to the glass on the left and to the glass on the right I'll add honey or shampoo or any thick syrup that you might find in your house. Now do not mix these solutions and leave them undisturbed for some time. Now let's observe what happens as time passes. Do notice the honey drop in the glass on the right. Let's see what happens after 10 minutes. The ink and the honey are evenly mixed in the solution on their own. Now, let's try one more activity. We'll need 1 glass of cold water and 1 glass with hot water, and we'll add ink to both of these glasses. For this experiment, I have 1 glass of chilled water on the left and a glass of hot water on the right. To both of these, I have added 1 drop of ink and I will leave them undisturbed. Now observe how the color or the ink particles mix in both of these solutions. What differences do you observe? As time passes, we see that the color hasn't mixed evenly in the cold water, whereas the entire solution with hot water is completely blue. From these experiments, we learned that particles keep moving continuously. We also learned that particles move faster when temperature is increased, and they move slower when temperature is decreased. Okay, we know that these particles keep moving continuously, but with such movements, why don't they just drift away from each other? To understand this better, think of what will happen if you try to press these objects very hard. Which ones would break and which ones would not? Now, think of what will happen when you try to break water. Can you really break water? The particles remain together because they attract each other. This force of attraction keeps them together and prevents these particles from drifting far away from each other. Now, which objects would have a stronger force of attraction? That means, which objects are hard or easy to break? A nail or a chalk? What about water or say some potato chips? Once you have thought about it, the answers are in the next slide. It might be easy to guess that it is harder to break a nail compared to a chalk, and it is harder to break a potato chip compared to water. This is because of the stronger force of attraction between the particles in a nail and a potato chip. So in summary, we see that matter occupies space, that is, it has volume and has mass. Matter is also made up of very small particles. These particles keep moving continuously. The particles of matter move faster when temperature is increased and slower when temperature is decreased. They remain together because they attract each other. But this strength of attraction is different for different things, as we saw previously.